Hello students, in differential calculus, so we have calculated the tangential line integral and surface integral and volume integral of scalar point functions. So now in this chapter, we will calculate the tangential line integral and surface line integral and volume line integral of the vector point function. For that, we have to understand two basic terms and basic concepts. What is, let's define oriented curve. What is oriented curve? Let us suppose this y is equal to f is a function whose curve is this, whose curve is this, AB's curve. Now, uh, either from A to B or from B to A, we can assume one direction as positive. If suppose we have suppose from A to B is positive, then B to A will be negative. And if the initial point, this is a curve orientation of curve, right? Now, if the initial point A and the terminal point B both coincide, the curve is called a closed curve. Smooth curve Smooth curve means if at every point of a curve there exists a unique tangent, then the curve is said to be smooth. Or if the curve is the curve function r is equal to ft is continuously differentiable at each point from A to B, initial point to and the terminal point, the curve is said to be smooth curve. Piecewise smooth. Piecewise smooth curve. Now this curve from A this curve. This consists of how many curves? C1, C2, C3, C4, C5. So now at these points, A at these points, this is A, this is B, C, D, E, F. C, C, D, E, F. A, C, D, E, F, B, we don't have unique tangents at the point. So at these point the curve is not smooth. So this such curve which are not smooth at certain points between them, they can be divided into finite number of piecewise smooth curve. This is piecewise smooth. This curve A to C is piecewise smooth. Up this C to D is a smooth, D to E is smooth, E to F is smooth, F to G is F to B is smooth. So if a curve is can be divided, if curve is not smooth, and that can be a finite number of smooth curves. Smooth curve means at every point from A to B on the curve, unit tangent is drawn, or the function is y is equal to ft is continuously differentiable at difference. Differentiable means at each point we have a unit tangent. So the first curve is not smooth, that can be divided into piecewise smooth curves. Now, smooth surface. Suppose we have a surface. Surface means we are talking in three dimensions. Okay? Surface means surface smooth if at each point of the surface we can draw unique normal. A surface which has a unique normal at each of its points, and the direction of this normal depends continuously upon the point on the surface is called smooth surface. Direction of the normal varies at each from point to point. If a surface is not completely smooth, that can be divided into piecewise smooth surfaces. Piece smooth surfaces, surface which is not smooth, that will be divided into finite number of smooth surfaces, and such surfaces are piecewise smooth surfaces. So the example of the smooth curve is circle, and piecewise smooth curve is a rectangle. Rectangle has four smooth surfaces. This is a finite number with four smooth surfaces. The rectangle consists of four smooth surfaces, and circle consists of a smooth surface. Similarly, in the smooth curve. Smooth curve is a circle smooth curve, and rectangle is smooth piece of smooth curve. Similarly, sphere is a smooth curve, and the cube is a piece of smooth. It has this eight smooth surfaces. Piece of smooth surfaces. Find out symmetry. Now, now these are terms which we'll use in this topic. And now, what is tangential line integral or line integral? Now, this is y is equal to ft is a function. This is a from a to b. And f at point p the position of the point p is r is equal to x r plus y is equal to zk. Now the force acted at point P and the tangent is along this direction from A to B is E vector and F. Now the tangential line integral of vector F along the curve, along this curve A to B, depend on the B along the curve from A to B is the definite integral of the this scalar resolute component of F in the direction of tangent. Resolute means component of this force F in the direction of the tangent to the curve measured from the fixed point A to the in the direction from A to B. From every point, this point, every point, we can find this. And the limit of integration is the limit of integration being the values of s corresponding to the point A. Integral from value of s at this point and this point. This is the curve. So this is called the line integral. If t cap is the unit tangential vector at any point P and F is the value of the force at P, then the tangential line integral will be of the curve from A to B is equal to A to value of S at A, value of S at B, F dot component. The scale result means scale component of the force in the direction of this S, their limits of S, so we are integrating to S. Now this will convert T is the potential component, rate of change of the position of the point at this point. S is cancelled, so this will be A to B F dot dr. If F vector is given in the three component form at any point, whose position vector is equal to vector is equal to x item y z. Therefore, dx is equal to dx component of this ds small component in the neighborhood of point p. Dx item dy is equal. If the line integral will equal to a to b, this is the value of f and dr. Scalar resolute will get the integral will be f1 dx plus f2 dy plus f3 dz. This is an important result. While solving problem, we use this time and again, and while using this, we remember everything. Now the important thing is the tangential line integral of a vector function f is 0 for every closed curve. 0. When will the tangential line integral be 0? 0 for every closed curve if an f is a gradient of scalar function. 0 only if the f is gradient of scalar function. Otherwise, the tangential line integral, the value of this integral depends not only upon the endpoints A and B, but also on the curve C, A, B of the path of the curve, endpoints of the path of the curve, but also on the orientation of the curve. So this will not depend upon the orientation if f is a gradient of a scalar function. The tangential line integral of f is independent of the path. When will it independent path? If and only if f vector is a gradient of the scalar function. Now let's solve problem based on this. The similar procedure I have discussed earlier will be used in every problem. So evaluate the integral over the contour C of f vector dot dr. So f vector is given to you, and the curve is the position of the curve is this, and this is given in some this in parametric form. The theta is from pi by 4 to pi by 2. Now r is given to us. Now we have to substitute value here. So in longer differentiating sin is to theta dr dθ. So after now df ds df dr can be converted into this is current form, so you convert it into df dr is equal to df dr d theta d theta. If you substitute dr theta, that's why you can do the derivative of this theta, this parametric form. Now substitute f and dr d theta and simplify it, find dot product, and this will become the integral will become a function of theta only. Now evaluate the value of the symmetrical, and this is the value of the tangential integral. Thank you.